Hey, welcome to Keem Explain. This is AIJI. Today we will discuss about Tyndall effect. What is the Tyndall effect? The Tyndall effect is the phenomenon in which the particles in a colloid scatter the beams of light that are directed at them. This effect is exhibited by all colloidal solutions and some very fine suspensions. Therefore, it can be used to verify if a given solution is a colloid. The intensity of scattered light depends on the density of the colloidal particles as well as the frequency of the incident light. When a beam of light passes through a colloid, the colloidal particles present in the solution do not allow the beam to completely pass through. The light collides with the colloidal particles and is scattered. It deviates from its normal trajectory, which is a straight line. This scattering makes the path of the light beam visible, as illustrated below. Generally, blue light is scattered to a greater extent when compared to red light. This is because the wavelength of blue light is smaller than that of red light. This is the reason why the smoke released by motorcycles sometimes appears blue. The Tyndall effect was first discovered by, and is named after, the Irish physicist John Tyndall. The diameters of the particles that cause the Tyndall effect can range from 40 to 900 nanometers, 1 nanometer equals 10 to 9 meter. In comparison, the wavelength of the visible light spectrum ranges from 400 to 750 nanometers. Let's show some examples of the Tyndall effect. Milk is a colloid that contains globules of fat and protein. When a beam of light is directed at a glass of milk, the light is scattered. This is a great example of the Tyndall effect. When a torch is switched on in a foggy environment, the path of the light becomes visible. In this scenario, the water droplets in the fog are responsible for the light scattering. Opalescent glass has a bluish appearance when viewed from the side. However, orange-colored light emerges when light is shined through the glass. How is the Tyndall effect responsible for blue eye color? The primary difference between blue, brown, and black-colored irises is the amount of melanin in one of its layers. The layer in a blue iris has relatively lower amounts of melanin in it when compared to a black iris, making it translucent. When light is incident on this translucent layer, it is scattered due to the Tyndall effect. Since blue light has a shorter wavelength when compared to red light, it is scattered to a greater extent. Another layer deeper in the iris absorbs the unscattered light. Since the majority of the scattered light is blue, these irises gain their characteristic blue color.